Hello, folks. My name is Andre, and I'm a senior engineer at Epsilon, developing tools to better understand and interact with data. And I'll be moderating the first three sessions until the break. And during those sessions, if you have any questions, feel free to write them in chat, as Damien said before in the opening remarks. And to start off, we are starting with a great speaker. His name is Rafael Pereira, and he's a versatile tech expert specializing in cloud technologies and project management. Rafael leads the platform unit at Epsilon, where he brings extensive experience in building scientific computing environments. And before his time at Epsilon, he gained valuable experience managing large-scale big data platforms, driving innovation and operational excellence in the field. Outside the tech world, Rafael has taken on an exciting personal project, restoring a beautiful mini classic car to its former glory. Please join me in welcoming Rafael Pereira as he shares his vision for building the ideal scientific computing environment. Take it away, Rafa.
Thanks, Andre, for that intro. You guys hearing me all right? All right. So let's get started. So good morning, everyone, or good afternoon. I am Rafael Pereira. I am the platform unit lead at Epsilon. So it's a pleasure joining you today. And today we're going to be talking about my vision, at least, for building the ideal statistical compute environment and the role that infrastructure as code has in this. One key caveat as well is you can call me Rafa. This is usually how people call me. And let's get started. So setting the expectation for today. So what I want to focus on the talk today is talking about the characteristics of what I think make an ideal statistical compute environment. This is obviously from the perspective of platform engineering. And I want to talk about tools and practices, mainly for scalability, reproducibility, and to achieve compliance. But I don't want to go too deep into specific breakdowns of tools. I will not be talking about the specific guide to validate environments. And our focus specifically is on the data analysis and compute layers of an SCE. So as we all probably know, if you come from a very regulated industry from pharma, then statistical compute environments can encompass a multitude of things. Today, we want to focus on these two specific elements. So a little bit about us and our unit. So we build platforms. At Epsilon, we make the bridge between infrastructure and end users. So our platforms specifically are tailored for data scientists and data engineers, and we mainly collaborate with infrastructure teams, not replace them. So we focus on getting best practices out of the way to create custom and customizable platforms for user bases. So we focus specifically on supporting statistical analysis, data engineering, and data processing workflows. From some of you who are not familiar with platform engineering, so this is basically the middle layer between infrastructure and users. So we specifically focus on provisioning, managing cloud resources for reproducible environments. We focus on scalable compute resources in cloud. We manage and deploy data science platforms, like, for example, the POSIT Stack, Domino Data Lab, Databricks. And we try to do all of this with infrastructure as code. I do not remember the last time that we actually deployed an environment manually. So this is typically always present in all of our integrations. We specifically focus on environments that are tailored for R and Python. So if you're familiar with Epsilon, then you know that R is one of the biggest things that we do. And our team is no exception. So we focus on these two main programming languages. So before we get started, let's talk a little bit about SCEs. So statistical compute environments, if you're from pharma industry, from a regulated industry, then you're probably familiar with this term. This can encompass a multitude of things. And these are typically platforms that are designed for statistical compute analysis and for data management in regulated industries. These environments typically can be validated, and they provide a control, secure, and in most cases, as I mentioned, compliant ecosystem for data scientists to do their work. So some of the key elements that we have from SCEs, they enable collaboration, reproducibility, they offer centralized compute, and they enable compliance on these systems. So as we talked about, let's think about, for example, in terms of the POSIT stack, let's think about POSIT Workbench Or let's think about, for example, Domino Data Lab and then its compute element, or Databricks with specific compute. So this is what we want to focus on today. So going into SCEs, let's talk a little bit about the challenges that we've identified and seen across some of these environments. So mainly, some of the challenges come related with manual deployments that happen in these environments. We see in some scenarios that usually GxP environments and non-GxP environments are very inconsistent and managed separately. Because of this distinction, from a platform perspective, sometimes we have a limited availability to basically test these GxP environments fully, because we're working with one environment instead of multiple ones. And usually, because compliance is one of the key indicators, compliance is one of the first things that we talk about when we want to implement changes on these statistical compute environments. So manual changes, environment configuration drifts between these different environments, and compliance slowing down progress and updates and changes is some of the concerns that we see here. Now, this is just to set the tone in terms of what some of the challenges we could face with statistical compute environments. But I also want to offer the parallel of a software engineering perspective within these environments. So, for example, whilst in traditional statistical compute environments, we have separated GxP and non-GxP, and typically we also have a prod and QA. But in software development, typically these three environments are consistent. So we typically start developing in dev, move to QA, and then move to prod. If we're talking about the compliant scenario, then the compliance is thought through from QA to prod. This makes it so that basically compliance doesn't necessarily drive the technical decisions. As we start developing in the development environment, we only start to worry about the compliance perspective when we actually want to move into production, which is usually not the case when we talk about traditional SCEs. So an additional thing that we put into place here is that changes from an infrastructure perspective or platform perspective are usually tested in QA before moving to prod. Because in statistical compute environments, the way that the environments are configured in some cases as snowflake environments, it can become a challenge to basically test it fully. Additionally, as a part of modern software engineering, we're adopting more and more automated pipelines and processes to ensure consistency. So this is a little bit of a difference, a different perspective to take a look into SCEs. And this sets the tone in terms of what are we going to look into today and how this infrastructure as code actually fits the bill. So one of the things that we want to talk about is cloud native. So cloud native approaches actually help us resolve some of the problems that we see before. The cloud native is basically is an approach of building and running applications that fully leverage the advantage of cloud computing. So cloud native is directly tied with cloud providers and cloud solutions. The main thing that we want to talk about when we talk about cloud native is the standardization of the environments. So because when we think about a cloud provider, let's say, for example, AWS, when we talk about the solution that exists within the cloud, this is consistent across their offering, right? So when we talk about EC2 instances, this is familiar across every environment. It's a system, it's a service that they offer, and it's something that is standardized. Because of this, this allows us to basically go into reproducibility. Because we use the same service, we can reproduce the environment, again, across, for example, a different account. This enables us to have a multitude of different environments that could differ technically in some configurations, but they are reproducible, and we can just copy and paste them over and over again. Because of this standardization, this also allows us to basically do some automation. If it's standardized, then we can achieve repeatable results, and we can automate it so that basically we reduce the manual effort in deploying and managing these environments. And as we all know as well, the cloud boasts the infinite scalability that we could potentially achieve there, and it comes as in stark contrast with on-premise environments. So I've seen particularly in situations where we need to allocate big pieces of machines or a lot of resources. And maybe for data scientists, this isn't very clear, or they don't have a lot of visibility into what happens in the background. But if you're operating a data center and you want to get these machines and you don't have them available, you have to go through provision to procurement. You need to get these machines, you need to put them into place, you need to do the installation, you need to run it through compliance if it's a compliant environment, and there's a long delay there, right? And you're limited to what resources you actually have available in your data center. In the cloud, that's not the case. You can just demand resources on demand, and we can also turn them on and off as we need. So basically, we can get some dynamic workloads going. Additionally, we can also think about cloud having built-in tools for regulatory alignment. So because these services are standardized and because the cloud providers offer SLAs and documentations and SOPs of how they manage the environment, this gives us a little bit of a leg up in terms of making sure that our environment is compliant. So we talked a little bit about the challenges. We talk about cloud native, and maybe you can already see how this technically could help us resolve some of the challenges that you might face with traditional SCEs. But talking about cloud native is important because it allows us to go into infrastructure as code. The cloud native approach is what enables us to basically go into this whole field of infrastructure. So infrastructure as code, we talked about software engineering earlier as well, and it would enables us to put infrastructure into perspective, just like we would software engineering. So infrastructure as code enables us to define environments as code, which then allows us to have this consistency across multiple environments. And it also allows us to basically version exactly the versions that are deployed. So treating it like software gives us a leg up, and utilizing the tools that we have available in the ecosystem allows us to reduce manual labor, and also it produces compliance as a byproduct. So imagine, for example, that you're defining an environment with Terraform, and I will talk about Terraform in a little bit. You develop the code, you put it in a code versioning tool like Git on GitHub or GitLab. This is already auditable, right? If you follow software development practices, this is going to be auditable, and you're going to be able to trace everything that happens within the environment. So change management becomes seamless, and with the tools available with Terraform and Ansible, you will also be able to generate some documentation and manage the state within it. So let's talk about a little bit about Terraform. So Terraform is one of the tools that we typically use to provision infrastructure in the cloud. So Terraform gives us a way to describe infrastructure as we would describe code. And this is an example that we see on the screen of, for example, a command called Terraform plan. So within a Terraform project, we can run Terraform plan, and it will tell us basically what are we changing within the environment of the code changes that we did. So in the output here, you can see, for example, that the plan is to add 2 specific new elements and to change 1. This is already a leg up of what we typically see with infrastructure. And this is a way that we can keep consistent track of changes in the environment at the infrastructure level. So if we tie this together with Git, then we keep change management in place. Ansible, for example, is another tool that fits into a slightly different category. Ansible is basically a configuration management tool. So if you look at Terraform and you think about Terraform as a tool to provision the infrastructure, Ansible is a tool to configure that infrastructure. So we could leverage Terraform to provision EC2 instances, and we can use Ansible to configure them. So this is the example of running a so-called Ansible playbook that contains the instructions of how to configure the environment. And this is the output that we get after running that specific playbook. So basically, you define specific tasks, and then when Ansible runs, it's going to compare the actual state of the configuration versus what we have defined now. So in this particular example, you see that there are some changes that are okay, some that will have been changed with this execution, and other examples. Obviously, this is available also for auditing purposes, and we can see exactly what was executed in the environment. And last but not least, I also want to talk about Kubernetes, because some of you might be familiar with Kubernetes, and Kubernetes enables an interesting aspect of infrastructure as code, because we can define applications with specific JSON files, now YAML files. I do not want to go too deep into actually what Kubernetes is and what isn't and how it does, because that's a whole talk in itself. But you can think about Kubernetes as basically the OS that would sit in the cloud somewhere. So you can deploy things on Kubernetes, and it will orchestrate that for you. So in this example here, we see, for example, the definition of a deployment of a compliance demo app. So in this case, we describe it via a YAML, we feed it to Kubernetes, and it will just manage it for us. It will manage the state and make the necessary changes with all of the necessary auditing in the background. So based out of these three different tools, we can take a look into two specific examples of how we could technically leverage IaC in an environment. And I want to present two specific examples. One is not fully provisioned with infrastructure as code, and the other one more towards that end. And the first one is, for example, as a part of we talked about with collaborating with infrastructure teams, we could request an infrastructure team to deploy us machines, be it on-prem or on cloud, and then we can use Ansible to basically configure the platform. So we define everything via Ansible code. We version control it via Git, and then we deploy the specific version that we want it to be deployed on the infrastructure. So in this case, part of the configuration is achieved via infrastructure as code. And the second example at the far end extreme is that we get a full provisioning with Terraform and then Ansible or Kubernetes in a cloud environment. A clear example of this would be, for example, if we request a specific client and we tell them to, or we ask them to give us a cloud account. So this particular cloud account, for example, and as a part of the collaboration with the infrastructure team, is probably already going to have in place all of the policies defined at the enterprise level. And these policies then are going to be inherited by the account. And as we define our Terraform code, it's going to live within these rules. So we deploy the infrastructure in the account via Terraform, and then we can do a full deployment of whatever it is that we need via Ansible or Kubernetes. So in the case of EC2 instances that we then want to configure and put something on top of that, we can do that via Ansible. In the case that we want to go a little bit deeper and in a more complex environment, we can leverage Kubernetes for this. And then obviously, as these are all tools that also leverage IaC, then we can all basically configure it and leverage it as we would with Terraform and everything else. So it's a full environment with infrastructure as code in place. So given these examples and giving these tools, I hope that we manage to see how we can leverage IaC for compliance purposes. So as a part of what defines an ideal statistical compute environment, I would just like to say that basically I wanted to keep it simple and define two major things. One is that an environment should be scalable and improvements should be continuously put into the environment. So future-proofing the environment through adaptability is key. In a world where a lot of changes happen nowadays, consistently, like just think about the advent of AI, right? And generative AI, it all happens so fast. So keeping up with improvements is a way to keep competitive. Beyond this, as a part of a perspective from a platform engineer, a platform is no good if the user is not at the center of it. So being able to empower teams with the specific tools and workflows that they need is that the key for any environment, be it the statistical compute environment one or any other one that we can take into account. So if we talk about like specific key features, I would say that these are the most important ones that we can see. Now, when we talk about what we covered here today, cloud native solutions are a way that we could leverage a lot of these things into place with the consistent services across environments and the scalability that the cloud offers. And then we can leverage infrastructure as code to be able to continuously improve these environments in an easier manner without exactly having to go too manual into it. And I forgot to mention one specific point that I think is relatively important. So as we talk about reproducibility within the cloud, we talked about reproducibility across environments. But it's also very important to think that cloud providers, they don't specifically just offer services for one company. They offer the same consistent services through multiple companies. So as we mentioned, somebody is going to define an infrastructure and an environment in Terraform, for example, they're going to give me the code. If I run AWS and the code is from AWS, I will be able to run it. And this doesn't happen across companies, but it happens across entities, across open source projects. And this is something very key to keep in mind, why cloud native could potentially be, or is, one of the major solutions that we can keep in mind for compliant environments. And as we're running through here, I hope that this presentation offered you an interesting insight of how we could technically leverage software engineering practices and leverage IaC into building compliant environments, and leverage all of the tools that we have into the ecosystem to make sure that compliance is a byproduct of what we do. I know that I'm not specifically talking about how we could technically validate these environments, and I know I'm not going too deep into solutions or automation itself, but we have a couple of talks today where we might be able to go a little bit deeper into compliance with Andy's talk as from a compliance expert, or specifically with CI/CD and automation with Ark's presentation. So thanks.
Thanks, Rafa. That was a fantastic talk, and there are already some comments on the chat from Christopher Ziegler, as he was pointing out that compliance as a byproduct should be the product itself. Any thoughts on that?
Should be compliance as a byproduct should be the product itself. Yes, what I mean with saying that compliance is a byproduct is that compliance is kept every step of the way when you're developing it. So from a software engineering perspective, you start developing the code, and as you apply the good practices, when you need to validate it, compliance becomes the byproduct of the artifacts that you generate. So the perspective that I was thinking about is just from the perspective of keeping it in mind every step of the way.
Okay.
I think Patrick has a question, comment of Docker in this context. Exactly. So let's see. So I didn't talk a lot about containers because I wanted to focus a little bit more on the infrastructure as a code side of things. But tools like Kubernetes leverage a lot of container orchestration in the mix. Not necessarily Docker, but containers. And Docker is a tool that can be leveraged to achieve infrastructure as code at the end of the day. So if you're familiar with Docker, then you know, for example, what the Docker file is. You can define your environment via a Docker file. You can define how a application is installed, how it's supposed to run via Docker, and then you can give that to different people to install and run on their own environment. So I specifically covered Terraform, Ansible, and Kubernetes because this is more tied in with the cloud native environments, and they all could technically leverage containers at the end of the day. But Docker is and containers are a very key element of making things reproducible. So I think it's an important tool to have in the stack.
Fantastic. I have a question before anyone else comments on the chat. And how scalable are these environments? Because if you pick on R, you have to support different R versions as they have different life cycles that need support. You have validated environments, non-validated environments. So you are building a bunch of environments that you have to maintain over time, and maintaining that audit trail and all of the compliance. Any comments?
So your question is, and how scalable this is from a management perspective, from an operational standpoint. So sure. Infrastructure as code actually allows you, I think, to scale things up and manage it at a very high complex level of things. If you think about, for example, how many applications you could technically deploy in Kubernetes, and if you think about deploying them individually, I don't know if you're familiar with Kubernetes, but let's imagine that you have to maintain 1,000 Docker files, right? And you need to deploy these individually as you do Docker build and then Docker run. It's not very sustainable to do in that way. But if you have something automated into the mix that would technically allow you to run these, like Kubernetes, for example, it becomes sustainable. I mean, The complexity that you can achieve with infrastructure as code is something that becomes, it's very big. Let's put it at that. And the fact that you can use infrastructure as code to make complex environments, it's not just the fact that it enables you to get to that point, but also makes it more manageable at the end of the day. You're managing code. You're not managing the state of the applications. You're not managing some of the outputs and how it should look like. You're leveraging the tools to do this for you. So infrastructure as code is also not just in terms of adopting the code and software development practices, but also to adopting the tools that enable it.
Interesting, thanks. And given that the how big it is and how many changes that are necessary if you are moving from a legacy way of handling the environment to infrastructure as a code, do you have any comments on how the collaboration with the client teams or with the infrastructure teams on the client side, how does this change management occurs, as it's a lot of training, a lot of different processes?
So I think one of the key elements that we could use from software development practices as well is modularity, right? So one of the key elements that also makes complex environments manageable is taking a look into it from a module perspective, from a box perspective. So think about setting up, again, so we talked about Snowflake environments in SCEs, but we can also talk about modularizing these environments. If one of these boxes does its own thing and all of these boxes do a lot of things together, you just have to focus on managing one box alone and not all of them. So in the case, for example, of collaborating with the infrastructure team could give you the box of the AWS account. And then you just have to focus on the box of what actually is that you have to deploy. From a platform perspective, what typically happens is that the infrastructure gives you the box of the infrastructure that you want to run things on. We, as a platform engineering team, we will give you the box of the platform that you're running, and then the users are going to give you the box of the code that they're running and everything that they do. So different levels of modularization make so that you can also manage it and manage more complex environments in a simplified manner. If you think about if you would do all of these changes manually without tracking code, it also makes it different because the effort of communication involved into it, like, it's significant, right? Every time that you want to push a new change into production, you have to go to the next team, and it's classical ops style, where you had hand it over to the wall, like, hey guys, please deploy this. And there's some strain associated with communication there. So the fact that you have it in code also facilitates communication in a way. So I would say that we haven't had a lot of problems communicating with the infrastructure teams. In some cases, for example, as two examples I gave them, we have more to do, get an AWS account and allocate everything from the get-go, or on the second thing, they give us the infrastructure and we deploy it. Collaboration is fairly easy, and I haven't seen any particular signs of strain on it.
Awesome, awesome. Oh, Patrick has another question. Are you aware of Coder, and could you comment on that tool?
Coder, I'm not aware of that. Oh, cloud development environment. Right. So this is something interesting, which is CDEs. So this is a new advent of things that are showing up, which is an interesting move that we have within the infrastructure space. So we are, while I can't talk about the solution itself, I can talk about the concept of it. And the concept of it is typically to leverage containers as development environments. So the precursor of this is a framework called dev containers, where you can define a development environment as a container for developers. And some of you who are data scientists and developers have seen about this. The next level of that is picking up this definition of dev containers and putting that into a cloud and into central compute. So there are a couple of projects that are popping up. Some of them are backed up by Kubernetes, for example, which enables these environments to run. And I think it's a very interesting type of tool in the environment that I'm looking forward to see what comes next.
Okay,
So,
thanks for that. We have another question by Conrad, and how to deal with scientific inefficiencies code that can generate unpredictable costs in cloud.
So typically, also as a part of infrastructure as code, is that policies become a little bit more clearly defined. And we can even add some custom logic on top of that. Where you have typically policies defined at the cloud level, you can also complicate this a little bit and define and interact with the code slightly differently. The way that typically this is traditionally resolved, and it doesn't really have to do with infrastructure as code, is to putting guardrails in place. So for example, you could have an infinitely scale environment with Kubernetes, and you could have at its availability tens of nodes that users might request access to it, but you need to put guardrails in place. So Kubernetes will allow you to limit the resources that these applications run. Kubernetes will allow you to limit the number of nodes that you allocate. So the best way to defend against inefficient code is having guardrails in place. I just want to comment that this is one of the reasons why the platforms need to be user-centric, because this is the alignment that you need to do together with the users. You can't have too many limiting resources or too much. So there's a lot of back and forth that happens with the users to try to understand what are their needs and what you can put into place, what is normal and what is acceptable and what is out of the ordinary. So resolving these scenarios is having limits and guardrails in place.
Okay. And those limits and guardrails also trigger notifications to the infrastructure team so that they can act accordingly, or just again expand the scale up the resources.
Yeah, one key point of this is that the cloud providers basically already have a lot of tools in place to enable this. There's a lot of FinOps type of thing that need to go into place to make sure that all of these costs are under control, but it's possible to do. So yeah, you're welcome.
Okay, thank you. I think that is all the time we have for questions. Feel free to contact Rafa on LinkedIn, or on his social media, or via the Epsilon site, and continue the conversation offline. And I'd like to give a big thanks to Rafa for his brilliant presentation and his enthusiasm and passion for infrastructure as a code, and that will bring a lot of already has brought a lot of change inside of organizations and will continue in the future. So thank you very much, Rafa.
Thanks, Andre. It was a pleasure. Hope it was useful for anybody.